Hello, this is the Artificial Intelligence final project, and we have chose to do Bitcoin future price prediction. Bitcoin is a new digital currency that can be traded online. Its price is very volatile, meaning its price changes very fast, and for this reason, people try to use like tools of science to guess it. So in our data, the rows in our data represent days and consists of 8 years. We have split our data as 80%, 20%, which is pretty common in AI studies. 80% being our training data and 20% are being our test data. We have employed a few learning algorithms in our project. Linear regression tries to fit independent and dependent variables into an equation, while moving average is a statistical approach that averages the last x days for guessing, x being guessed by the algorithm as a parameter. KNN tries to estimate a value comparing it with its x neighbors, x decided as a parameter by the programmer this time. Long short-term memory, which is abbreviated as LSTM, is an artificial neural network that decides to keep or forget the past information to make an educated guess. It can do best with time series, which is our data that is sorted in a timely manner. And lastly, in our project we have used and compared different RMS values to see how accurate our algorithms do. So in our first example, in our first algorithm, the linear regression, we have created data columns actually, such as day of the week, day of the month, like is Friday or is Monday, from the date data column, as there's a correlation between this and market behavior, which is the price actually might depend on the which day of the week it is, or is it Monday or Friday, which is when the markets open or close. Our guess is good to catch seasonal trends, as it showed an increase in the December of 2019, just like in December of 2017. Yet the values are very far from the actual ones. And moving average didn't do so good either, because actually the first half of our data is very calm, and this can actually mess with the prediction averages. In k-nearest neighbors, we have tried the different parameters to see how it affected the outcome. From this, we can maybe say that the lower values of n neighbors is more accurate at predicting. In LSTM, actually we have two parameters to set. Trying a few values and making some research, it became obvious to use a batch size as 7, since market behavior, like I said, depends on a weekly cycle. And epochs mean the number of complete cycles through the whole training dataset. And for epochs, the better the results become as we use more epochs and we go over the dataset over and over again to train our data. This is all. Thanks for listening.